So here's an example of a math question created just so that we could do math, but not very realistic whatsoever. Because this situation always happens. Clara and 3 friends are always born on the same day. Leslie is 5 years younger than Clara. Mike is 2 years younger than Clara. Thomas is 3 years older than Clara. Right? And so you happen to know, this is what I love, you happen to know that the product of their ages is 61,136 times 36 greater than the sum of their ages, but you don't have the social ability to ask Clara, how old are you?
Yeah, Clara, how old are you?
I mean, but you happen to know this other really...
Such different age gaps.
This is just... So yes, this is an example that's just done so that we can do math. It is not very realistic whatsoever. Whereas the first questions I felt were actually good real-life word problems that have a good use. This one does not. But we'll still solve it anyways. Everybody is compared to Clara. So we'll say that Clara is X years old. That means that Leslie, how old is Leslie? X minus 5. How old is Mike? Mike is 2 years younger. He's going to be X minus 2. And then Thomas is 3 years older, so he'll be X plus 3. So they're all compared. Now we have to create an equation using that 61,136 knowledge. The product of their ages, so I'm going to just start with words. Product is 61,000 greater than the sum. So if I put the sum on this side, where am I going to put the 61,136 so that they're equal? It doesn't matter which side. We just have to either put plus or minus, right? Does it make if I put it on this side, does it make sense that you'd have to add it? Because this is the one that's greater, so in order for them to be equal. So now that we have the words there, we can write the equation. The equation would look like this. Product. Well, that means multiply them all together. Oh my goodness. And on this side, the sum, if I add them all together, can you see that you're going to get 4x minus 4? And then we still have this plus 61,136. Whew. It is useless, right? We should have just asked Clara, how old are you? And if she doesn't tell you, ask Thomas, right? And I just picked him next. And then Thomas doesn't tell you, ask Mike, right? And if they all don't say, ask Leslie, she's the youngest, and tell her you'll beat her up if she doesn't say. And she'll probably tell you. That's bullying, but it's probably better than doing the math, right? This is a bad question. It's teaching you that you should bully instead of do math. No, it's such a bad question.
If you don't do this, I'll graph this parabola. Yeah, bet.
Yeah.
Say I won't.
Okay. So you have a couple of options for solving this. Again, what this is doing a good job is teaching you some graphing calculator skills that are going to help you in IB next year. Okay? One of the skills that's really helpful is if you have two equations like this and you're trying to solve them, you can type one of them into y1 and one of them into y2. And if you find out where those two graphs intersect, that will be your solution. So we'll start with that solution. It's different than what the textbook does, but we'll start with that one because I like that. So we go y equals, clear this out. The one side was x times x minus 5 times x minus 2 times x plus 3. And on the other side we had 4x minus 4 plus, and you could have combined those if you wanted to, but you don't even have to. Your calculator will figure it out. Oh, 4x minus 4, right? Oh, there we go. 4x minus 4. So you could have just done plus 61,132. That would be fine. Now, the problem with this method is sometimes when you hit graph, so there's my one graph, and I don't see my other graph. Do you see that as a problem? Because if you want to find out where they intersect, which graph don't we see? We don't see this one, 4x minus 61,132. What kind of graph is that? It's a line. What's the y-intercept of that line? 61,132. So our knowledge about graphs comes important here because if I want to look at my window, I would need to have at least 61,000 in order to see my y-intercept. So maybe I'll go up to 100,000 and see, can I see both of my graphs now? Yay! I can see both of my graphs. Unfortunately, I can't see where they cross yet. So I'm going to have to go your window, zoom, here, start with zoom 6, and then we'll go from there. So now I'm going to go to my window, and I need to see further to the right. I'm looking up to 15. Maybe I'll double it and look up to 30 to see if I can find out where they cross. Yay! And to find out where they cross, second, calculate. Number 5, the intersection point. Push enter 3 times. And Clara is 17 years old.
Yeah, can you show your window,
What's your Y max?
I put on 100,000. So it's a word problem, so we should end with a sentence. Claire is 17 years old. So that's method 1, typing something into Y1 and something into Y2. Method 2, you could have moved everything over to one side of the equation. So let's say here, method 2. If I subtract the 4x over, and this is 61,132, I subtract 61,132, then this side would equal 0, right? And now I'm going to graph the left-hand side into y1. So I'm going to go to my calculator, go back to y equals. I'm going to clear this one out. And write minus 4x minus 61,132.
Does the 4x plus 4 or 4x minus 4?
No. I simplified the minus 4 in the 61,136 when I brought it over.
But if you didn't do that, it would be minus bracket 4x minus 4.
And so, yeah. And so now what we're looking for, because we made it equal to 0, is we're really looking for an x-intercept. The nice thing about this is that based on the context of the problem, if I'm looking for an x-intercept, okay, for my y-min and y-max, I don't need to go that high. I could just go from negative 10 to 10. I'll see my x-axis, right? When thinking about my x-min and x-max, We're trying to find an age of Clara. Do you think she could be -5 years old? No. Do you think she could be 3,000 years old? No. Yeah. Probably, I would estimate somewhere between 0 and 100 first. So now if I hit graph between 0 and 100, does the graph ever cross the x-axis? Yes. And that's when y is 0. And since we set one side equal to 0, now we're just trying to find that x-intercept. Two ways you could find that x-intercept. One is you could calculate number 2, the 0. That's your x-intercept. Pick a value on the left. I chose 5. Pick a value on the right. I choose 50. Yes, it's in between those two. Press enter, and you find out your x-intercept is at 17, which we already knew Clara was 17 years old. It's not an intersection now. Now you're finding a 0. If you wanted to do an intersection, what would we have to put into y2? 0. If you put 0 into y2, then you could use intersection. So then I can go second, calculate the intersection, curve 1, curve 2, enter, 17. So if you'd like to practice some useless questions, numbers 7 and 8. There is a useless question on your take-home quiz, as well as some useful ones.